Okay, so today's Leetcode daily problem is final array state after k multiplication operations. So we are given an integer array nums and an integer k and a multiplier. So we need to perform k operations. So 5 operations on this array, and in each operation find the minimum value in nums. So suppose 1. Okay. Select the one that appears first. Okay. Replace the selected minimum value x with x into multiplier. Okay, so instead of 1 we have 2. Now after that 2 is the smallest, so I get 4. After that this 2 is the smallest, so I get 4. After that this 3 is smallest, so I get 6. After that this 4 is the smallest, so I get 8. Replace and run an array. Okay, this is a simple ad hoc problem. um uh, yeah, it is a simple ad hoc, like simply we have to implement the stuff whatever is given. So multiple occurrences, what I can do is I can um, iterate over the I think I have to iterate k times, right? Because I need to perform k operations on the array. So I'll iterate k times. Let's call it operation 1, and so yeah, I'll iterate over k times, and in each iteration I have to perform this. Find the minimum value x in nums. So they're calling it x, I'll also call it x. Okay, if there are multiple occurrences, select the one that appears first. So if I have to select the one which appears first, maybe I can start with the last, and x is equal to min of x, comma, and I also take the position. Okay, so I'll say if x is greater than nums of I, then I have to update with two nums of I, and I also have to update position to or greater than equal to, because yeah, we are iterating from zero, so we need the smallest position. So position equal to I. Yeah, I get the position, and in here what I have to do is replace the selected minimum value with x into multiplier. So nums of position will be equal to nums of position multiplied by multiplier, right? And I have to return nums. So this is like a O of n square solution, obviously, because we are iterating twice in a loop. Let's see if it works. Yeah, it works. Should we? What are the constraints? Okay, 100. So this should work. Like the constraints are pretty small, so it should work. Yeah. Okay. Cool. Okay. We can also think of optimizing it. Uh, Basically, we are running this inner loop to be able to find out the minimum value, right? What if I basically we need some data structure which holds the values in a sorted order, which is obviously a min heap, right? I think I've forgotten how to initialize a min heap. Wait, I'll have to check min heap sequence. I'm doing DSA after long, so let's see. Okay, it's just like this. It's a max heap. from min heap, I think. Okay, from min heap we keep all the details. Yeah, so I'm creating a min heap. Okay, I can say I less nine plus if you dot push nums of I. So I am yeah, I'm pushing these items. Okay, so it is a min heap. So the minimum item will always be at the top. But okay, I also need the your index. So it should be a pair of index, right? Yeah. So in here I am pushing nums of I and I. Okay. So it will first like sort based on nums of I and then sort based on I. Uh, okay. So when I'm going through this, I can simply say x is equal to pq dot first, and here I can say dot second, and I can get rid of this item. Okay, where am I using x? Okay, basically I only need the position, right? I don't need the number. Okay, yeah, the number is x. So like yeah, okay, yeah, this is fine. Let's see if it works. It should work logically. 2 2 3 5 6. Okay. Okay, right. I'll also need to update the array, right? So, right. Basically, my priority queue will have will not be updated with the new numbers, right? So here we had elements. So suppose it was like 1 2 3 5 6. Now here in X it returned 1. Okay, position wise this was 1, index 1. Okay, so in the array it is updated, but the priority queue also needs to now account for this, and it needs to get rid of this. So see, I can automatically get rid of this by running pop operation. Okay, and after this I'll have to again run pq.push. I'll have to push the new number, which is this, and the position. So now this should take into account the values which we have changed. Right, it works. So this will have much better time complexity. Like we're only running this O of n times. These operations also have some time complexity. I'm not sure. Let's check the time complexity. Complexity of min heap pop operation. O of log n. So yeah, this is like O of n log n time complexity. Yeah, we have submitted it, right? Okay, the the earlier solution was faster according to Leetcode. Not really.